Hey, I'm Carm and welcome back to the Build It Basement. Today we're starting a new chapter in our Voron 2.4R2 ultimate build. Probably almost like a second book at this point. We're working on the electronics. We're starting to work on those. We're going to get a bunch of stuff mounted. So let's just jump right into it. So, how y'all doing? Hopefully you guys are enjoying the streams thus far. I will point out right now, this is an LDO kit. And LDO went sideways in terms of what they're doing here with this kit. For better or worse, till death do they part. They're doing things different than the Voron team has. And we'll see, maybe in a future revision, we'll see some of that stuff meshed together because it's all fluid, right? So, general parts here on the desk, just go over this real quick, what we have out here. We have our control board, we have our stepper drivers, we have our 48 volt power supply, which is switched to 115 straight out of the box. I don't think I did that, but maybe I did. If it's not, you're gonna wanna switch that to 115 from the 230 it may be in. We have our SSR, our solid state relay. That's going to take a DC voltage that we have coming out of the controller to control the AC voltage is going to the bed. It allows this Voron printer to heat the bed up extremely fast. We have our Raspberry Pi or whatever version of Pi you have, or whatever board you can find that will fit your needs because, yeah, because of COVID, right? We have mounting hardware. DIN rail mounting hardware. We have adapter plates to go on Raspberry Pis to go on controller boards. We have specific parts to the LDO kit. We have these terminal blocks. I have these Wagos here just to kind of show them. They're not used in this LDO kit, but I already had the part and I already have tons of Wagos because I love them. And maybe I'll try to incorporate those still. I don't know. We'll see. Kind of iffy on this whole terminal block thing versus a Wago, but who knows. A couple M4 screws, a couple of self-tapping screws. Pretty much the only self-tapping screws used in this whole thing. And then our power inlet with fuse in that as well. Excuse me, I'm still dealing with a little something in here in my throat. If you've never dealt with one of these, just quick. The fuse in this, there's a little notch in here. You pop it right up. Fuse is right there, and you pop it right back down. It's pretty much just a fuse holder. Comes with a fuse in it. They also give you a package of a couple other fuses in case you're gonna go all pyro and blow out fuses, which you probably shouldn't, but who knows. I got some cable covers, a bunch of cables, a bunch of other stuff. Mechanically 90% built printer to my right, and to my left, a camera to videotape all this. So let's jump into the PDF and take a look at what the Voron team says we should be doing. So electronics, there are DIN rails, our Raspberry Pi, and what is that? That is a 5 volt power supply, which is not included in our kit. Now, again, for better or worse, till death do us part, the LDO kit comes with the Big Tree Octopus, which is capable of supplying 5 volts to your Raspberry Pi without the need of a 5 volt meanwhile power supply or similar. I have mixed emotions about this. At the one side of me, that should be just fine. That Big Tree Tech Octopus should be just fine, 100%. But these beefy meanwhile power supplies are pretty snookum. They are very nice power supplies. And if anything's to go wrong here, you're basically looking at power supplies or corrupted data of some sort happening somewhere, possibly a burnt out stepper motor. Everything else should probably work for a decade or more. You know, except for mechanical stuff that wears out. It's, you know, so mixed emotions on that one. All right, so they give you a layout here, and at the same time, let me see if I can pull up the layout for the LDO version, which is slightly different. Okay, let's do this. Let's screen share that. So the LDO version, for one, has the DIN rails facing a different direction. On the Voron version, they face, we'll say left to right. LDO, they're up and down. Okay. There's kind of a well, it's a photo. It's more than just a visual representation of what we're doing. That's exactly what we're doing if we do it exactly to the LDO kit. Good things to know here. So here's the Octopus right there. There's a 48 volt power supply. Those are the two biggest things on the bottom side here. Raspberry Pi. You can use an Orange Pi or any other type of Pi. There are tons of videos out there. Nero just recently did one as of February of 2023, utilizing a different type of single board computer. Golden Jaguar has another one where he uses a Google TV device that he manages to finagle into a piece of hardware to run Clipper. So pretty much anything that has an ARM processor will suffice for this, but we have our Pi. We're going to use our Pi. Mine's a 2 GB version. You could get away with 1 GB version, not an issue. You have your SSR, and then you have your terminal blocks here, and then you have your power inlet. So let's start by getting back over to the Voron version here, because they're going to show us how to put together these. So every component that mounts to the DIN rails on this printer is going to have a specific mount for it. Only makes sense, right? So the first one they're working on here is the Raspberry Pi one. That Raspberry Pi one basically is utilizing a single mount with a single clip because it's very small, doesn't have a lot of weight to it. So let's get right here. So we're looking for something that looks similar to that. You know what? I'm missing a light. Let me get a light on for y'all. There we go. A little brighter, a little better. Better and brighter. Something like that, right? And that mounts to one of these guys. And there are screw holes on these. These go straight through on both. You'll notice if you pull the wrong one, the screw holes don't match up. Screw holes don't match up. Screw holes don't match up. Screw holes do match up, okay? These are the same. I may have extra ones just because I made sure I had plenty. This does have little nubs that stick up. That's to basically give it separation between the mount and the board because of the solder points. So the first thing you're going to want to do is to assemble your mount to your clip. And that's going to look something like that. So the mount to the clip is going to be held together with some little self-tappers. I'm not a big fan of self-tappers, but I guess if there is a case to use them, this would be that case. We are just going plastic to plastic, so it'd be good. So me saying plastic, plastic just reminded me of something today. And I don't know if you know, if you care, but recently just got my first patron on Patreon. I'll talk a little bit more about that in a bit, but I just added some swag on there, some Build It Basement t-shirts and mugs for people who do become patrons. I forget what the levels are exactly, but yeah, kind of cool. So there's that right there, real quick, real easy, simplistic. And once we do that, we're going to bring up our Raspberry Pi like so. And our Raspberry Pi, again, orientation's key. I like to keep my orientation the same as what you see on the photos in the manual, if you can. Now, if you're using a different type of device, you will need to source a different type of mount. Luckily, if you're handy with the Google search and the GitHubs, you should be able to find mounts for quite a few things. If you can't find one, you know, it might be a great time to learn a little bit about something simple like Tinkercad. These mounts aren't very complicated, so good opportunity to learn something like that. What I'm going to do, I'm going to try, let's go to this camera real quick. Let's see here, overhead, and let's Yeah, zoom in like that, and then make sure our, yep, there we go. This might work a little bit better for everybody watching. You can actually see from top down view. You don't need that super close video for this. There's no magic going on really. So again, we're using these self tappers. We're going directly into plastic here, so you don't need to wrench or crunch these down as hard as possible. They just basically are there to hold this equipment in place, and none of this equipment is very heavy. So little thing about ESD, electrical static discharge, especially if you're in a drier climate and it's winter, you may want to be a little bit careful dealing with some of these components, specifically this Raspberry Pi, anything with any ICs on any integrated components on the boards. Devices are relatively rugged, but today, for the difficulty it is to find a Raspberry Pi, something to be aware of. So maybe a touch of ground before you start working, or you could have a grounded work surface if you so feel you needed it. All right, Raspberry Pi done. What's next? The 5-volt power supply that we don't have. So we're skipping over that one. And the 48-volt power supply that we do have. So that's getting feet directly onto it. And again, orientation. Got my terminal side where I want it. Kind of matching the picture there. And that is going on using some M4x6 screws. And this is using the beefier mounts for that. And those are going on like that. And it's going to take 4 screws. And a bigger screwdriver. One. I mentioned it in the beginning of the video. I will mention it again. On the side of this, there is a switch that goes from basically 220, 230 to 110, 115. Make sure you switch it to the proper voltage for where you're at, which pretty much means if you're in North America, you want it to be at 115. And if you're in Europe and most other places in the world, other than maybe Japan, I think, you're gonna want it at 230. Maybe I'm wrong. If you know when I'm wrong and you're in Japan or something, let me know. Comments down below. I like the comments. All right, so we got that bad boy put together. Set that one aside. And what's next? Controller board mount. Okay. So, controller board mount. These are the mounts for the Octopus. And if you look on these parts, it's kind of hard to show on camera because it's just barely there. But these have imprinted on them what they go to. Yep, on both of them. So these say Octopus on them, so I know they're for an Octopus. You can have one that says, I don't know, what's the other, Spider. You could have one that says that on there. It all depends on what the board you have is. So we're gonna mount that to the feet here in a second. And then we're gonna go over that board a little bit more. We're gonna kind of go off the manual a little bit. We're gonna put the stepper drivers on there because there's no reason not to at this point before we mount it onto the printer. And then we'll talk about that a little bit and some of those inputs and outputs, because I'm sure there are some people out there wondering what the heck they're getting into at this point when they see those connection points. All right, so that goes like that and like this, I think. Again, these have the little nubs on the tops of these that allow for a little spacing between it and the Well, that ain't gonna work, is it? There we go. For it and the circuit board itself, so that you're not crashing into the solder. This is the fun way to do this. It's called the helicopter method. And number 2. And the way I have these right now, and I think they're right, we'll fix it if it isn't, but intuitively I'd like them to go inwards, but they're going outwards. So this one right here is going to go on this way, again outwards. I should say counterintuitively. Now counterintuitively on the first one, and if you made a decision on the first one, then the second one should be intuitive. Right? Leave a comment down below and let me know. I gotta tell you guys, I'm really having fun doing this build. Hopefully you're having fun watching. I am open for questions. If you take a look at any of my videos, I think I answer every single question. So feel free. And let's see, let's clip that closed. All right, where are we at now? All right, we are at controller board mounting, and then mounting that to, what are they showing here? Oh, we used a dummy to, okay. They used a dummy. I already have plenty of dummies, so I don't need another one. All right, let me get back to our controller board. So we're using the Quicksitx Octopus. This is what came with the LDO kit. Now here's what I'll say about this in particular with controller boards is manufacturers, whether it be a Voron kit or LDO kit or whoever's kit, they are known to switch out controller boards depending on what the new hotness is or what's more readily available. So I will say that there is a probability of some sort that you do not have an Octopus, but there's also a probability that you do, right? So that's that. And where is my screen that I want? Yeah. All right. Let's talk a little bit about this Octopus. So about a year ago, there were 2 big boards that came out. There was a Spider and the Octopus, and I think the Octopus kind of won things out, being slightly higher quality, even though the Spider had a Voron version, the Quicksitx Spider. There were a couple of revisions and things, and I think there was just a couple of issues that happened here and there. But this is pretty much your big Quicksitx Octopus. Looks like it's on sale right now, so if you want one, get one. I have no affiliation. I make nothing. And again, that price is as of February 2023 in the United States. Could be different where you are and when you are. So there you go with that. Anyways, moving on with things. So I'm not gonna read this whole thing off to you, but basically an ARM processor, like we talked about before, has an input voltage, 24 volt DC. It will, forget how many steppers it will. I think it's 8 steppers it will take on this thing. Yeah, 8 steppers. You have bed power, bed out, motor power outs. You have multiple hot ends, up to 4 of them on here. Multiple fans, end stops up the wazoos. You have the ability to do a CAN bus on this. Wi-Fi, a TF card, USB Type-C, a UART port if you want to use that. BL touch port, reset button in case you need that, in case you need to flash firmware the hard way. Hopefully we don't have to do that, but if we do get into that, so be it. Let's see what else we got here. UART mode, SPI mode, yep. Cool, yep. So what we got for an ARM processor? STM. So you'll get familiar with STM software if you ever have to flash firmware to a board like this directly. There is software from STM to do that. And let's see here, it's got a ton of stuff here. Yep. Cool. All right, back to this. So let's see if we'll get these mounts on here first. And I think the best way to do that is going to be like so. We use some M3x6s to mount from the board to our mounting plate. And I'm going to keep these on the inside so it doesn't take up any more room than it needs to. If we put them on the outside, we might cut ourselves short. So let's put that on like so. Zoom out just a little bit here. There we go. And oops. Just going to take that and give it a couple of tweaks. Just kind of get that screw started. Once I get that started, we'll get this one on there about 90%. And then the other side of that. So back to the static electricity thing. So one big thing when you're building a printer like this, especially when you get to the electronics portion of it, I highly suggest if you are working again in a climate that is dry. You know, I'm in the Northeast and it's wintertime, so it's dry here. I do run humidifiers in the house to try to help that a little bit. But the big thing is, do you have carpet under you right now? If you have carpet under you right now, be afraid. Be very afraid. It doesn't take much to cause you to have a bad day with this stuff. One of the great things about this hobby though, and I know everybody's different, but for the most part, not for every part, but for the most part, most of the components are relatively inexpensive. Like you saw, this board, which could easily be worth 10 times what it's sold for in terms of, you know, how complicated things look. It was under 50 bucks. So the world does not come to an end. There we go. Perfect. All right, so we got Octopus and we're back here with the LDO dock, and we need to adjust these jumpers, I think. That bring confidence to you. So if you look here, you see these green jumpers on these stepper on the driver, where the driver is going to connect to these, and they only have one in the second port. They have none on the first, third, or fourth. On our board, straight from package, we have steppers, or jumpers I should say, on all ports. So we're going to be removing some of these. That one. And I'm going to get better tweezers too. Actually, you know what? This will work just fine. These not have the little. These not have the little wings on them I'm used to. Oh, they're there. Get rid of that guy. Get rid of that guy. And we're gonna do the same thing all the way through. So basically we're leaving just the second jumper in on there. So if you're looking at that board, right there, focus. So if we're looking at that board right here, that is, that one's blank. That one has a jumper in it, blank, blank, blank. And we do that all the way across. So someplace in my stuff, I actually have a little tiny thing that takes jumpers off really easy. And there might have been one with this kit, but I'm not gonna go looking for it right now. So the purpose behind this is for different configurations with different steppers. If you were buying this separate and you weren't following, you know, a specific kit, chances are you'd still be putting these jumpers in the same spots. However, if you were printing or building a different printer, possibly using different firmware and different drivers, you would possibly be putting these in differently, or maybe even leaving them all in. Do not throw these away. You may find a future use for them. If not on this board, maybe a future board. Ugh, we almost lost the heatsink. Where's that? All right. Done. All right, and we're getting there. Oh, halfway's done. And I'm just going to start pulling these right off, and then I will dump the board over after, just to move things along a little bit quicker. Because I hate editing video. Plus, this isn't a cooking show, if you get the reference. All right, and take a double look, see what we got. We're good. I'm gonna take the first box for the first stepper. I am going to remove it, put it on that, and I'm going to put all these loop jumpers in this first box. And I'm going to miss half of them, because that's the way it works. There we go. All right, back to where we were. All right, so these are your steppers. These guys right here, these are your drivers. And basically these are taking the, they're basically switches. That's what they're doing. They're sending pulses to your stepper drivers. And the reason why these are socketed is because these could, they don't very often, but they could go bad or could blow. You know, things could happen to them. It'd be a shame to throw out the whole board with just one bad stepper driver. So if you look on these and then look on your board itself, because these are from the same manufacturer, Big Tree Tech, they are color coded, red to red, black to black. One thing I will say is I have had experience in the past where these pins may be slightly askew. these ones look pretty good. So basically you're just gonna line them up, push them in, like so, yeah, okay. Once you do that, you have heat sinks. Interesting thing about that is the actual IC is underneath this, but they give you this big copper pad here to stick that to. Now, quick suggestion is to get some isopropyl alcohol, something with a relatively high test to it. You don't want to use like the 80% or anything, and just make sure that surface is clean. Give it a few seconds to dry off, and then stick your heat sink to it. Now when you stick your heat sink to it, make sure you're not touching any of the pins. You do have some pins that come up along with that on that stepper. You want to make sure that you're not touching those with your heat sink, okay? You want to try to get on there square, make sure you're not touching any of the pins that go along with it. I'm going to go ahead and quickly get the rest of these all on. So and if I think of anything good to say while I'm doing this, who knows, maybe I will. So don't fast forward. Remember, we used the first box to put our jumpers in. We can keep those. I think I have a box with another 100 in it or so. I like to do things in a production line kind of situation. So I'm going to mount all my steppers and then I'm going to put all my heat sinks on them. If you get to a point where you're running things when you do your first software checks and something isn't working right, one of the first few things you're going to check is whether your drivers are in there properly, because that can happen. Like I said, I've had some where the pins are just slightly askew. These are relatively close together, so it can happen. You do want to try to push them down nice and square. If you go down at an angle, you're going to run into issues. Speaking of issues, these guys are tight, side by each. The foam that these are in is anti-static foam, even though that's usually pink. And we're going to wind up with one empty space on the end here. Because we don't need that last one. And then, I don't recall, but I think like on the spider board, the two on the end are actually controlled by the same stepper. So you don't really need it. I don't think that's the case on this though. There's a jumper usually to manipulate that. Okay. So basically what you're looking at here, not necessarily in the correct order, is your extruder, your 4Z, 1, 2, 3, 4, and then your AB stepper motors. And just for the neatness counts, I'm going to try to get these all in the same approximate location with the same direction. If you wanted to go crazy, you could take the thermal pad off of these and use thermal glue. I don't think you need to, but you could. And all 4 people going an extra mile, so that's up to you. A lot of times, steppers like this are actually driven without heat sinks even on them, so. Voron is capable of driving these pretty hard, so I don't suggest you do that on this build, but just a note. All right, so there's that. All right, let's go to the overhead real quick. We have our board, we have our steppers, right? And let's go back over to our screen. All right, and now to get into wiring, so let's get over to our PDF. Something else we can do. All right, so let's go ahead and get the soldering station queued up here. Yep, and we're going to mount the heat certs into our input socket. Now, you're looking at right now the one that came with the Voron kit. However, I don't know where it's shown or if it's shown. The one on the LDO kit is a little different. I'm going to show it here. I don't see it. It's not there. Let's see build notes. Not there either. Okay, well, I'll show you. So soldering iron's heating up right now. The difference is this part you're going to print separately. It is in the LDO documentation. Let's see, sports stopper, clock insulated inductive probe. He does not use 5-volt power supply or Wago connectors. Yep, we got that. It references page 184. Use 1.2 millimeter AC outlets, integrated switch, plug panel. Refer to the LDO wiring guide. I didn't see it in there, but they say to refer to it. So that being said, that is this guy right here that we talked about a moment ago. It's a little bit different because the switch and the power inlet are integrated. A lot of times the power inlet is not integrated with the switch. They've pre-wired the switch to the power in. The ground is not hooked up and the output from the switch is not hooked up. Now, just a safety note here, and I'll note it again if I remember, but once this is plugged in, all of this is live, okay? So if you have this plugged in, even with the switch off, okay, these terminals are live, okay? So you're gonna be dealing with AC voltage, very dangerous. So treat it with the respect that it should have due. You know, you could probably get away with touching it and feel a tickle, but you possibly couldn't, you know? It all depends on where the electricity decides it wants to go that day. So keep that in mind. So we're heated up here, I believe, and we have, I'm gonna kind of go back to this. We have heat certs going in right here and right here. Get those ones in first, those are the easy ones. I'm not a huge stickler on keeping heat certs perfect, honestly. Plastic is relatively meldable unless you're using a plastic that isn't, but this ABS is. If you are in there within a degree or two, you should be just fine. More importantly is if the manual calls out that your heat cert is 100% beneath the surface, make sure it is. This doesn't say that specifically, but I always try to get them at or slightly below the surface. And I do like to push them in slow. I see some people put them in like they're putting in pop rivets, and there's just no time for the plastic to meld into the grooves and slots they're on the heat certs when you do it that way. So I'm not quite sure why some people do that. All right, so we got those two on. We don't need those two. And then the one here on the top we need to put in. Reading heat certs is a little zenish. Okay, so we got those two. We don't need on the manual. They show two more going in on the left and right, flanking the left and right of what would be the switch, no, the power input. We don't need that for ours. So we need the two where the accent piece is going to go, and one on the bottom side. So I'm going to set my soldering piece aside here and make a mess at the same time because I'm good at that, and get back to this. So let me just make sure, and I apologize for swinging this back and forth so much, but let me just make sure that we put this on the right. This can go in either way, up or down, and I want to make sure we put it in the right way. Let me see here, if I can get a picture of it, that would be great. Not an exact picture of it there, but I am familiar enough to know that that goes there, and if the blue wire is on top, that we should be putting it in like so. So if we're looking right here, we see blue wire on top, red or brown wire on the bottom, heat cert right here. So I am going to again line myself up, similar to what they have in the manual, and firm push in, snaps in place, nice and good. Look at that, finished piece, right? I'm gonna take these other heat certs and set them aside, and back to the PDF we go. All right, that is the SSR. So the SSR is interesting because it comes with its own mount. I don't quite know why the SSR and only the SSR has its own mount, but it's the way it is. I put mine on my printer temporarily for safekeeping, so we'll put it back. All right, so here's our SSR. One thing to know about SSRs, this is an Omron, which is a good SSR. It has an LED light on it, and it's going to flash when you're using it. Negative thing about SSRs is when they fail. Okay, when an SSR fails, it will fail powered, meaning that it will stay on. So that's kind of one of the reasons why you have a thermal fuse on your bed. Actually, it is the reason why you have a thermal fuse on your bed. If this failed powered off, it wouldn't be such an issue, but if this fails, it fails powered on. So that's why you don't skip the thermal fuse on your bed. Simple as that. So I'm gonna take this, it's gonna go like that, and get a couple more of these M4x6s, which there aren't a lot of M4 screws used on this printer, so you may have to dig for that bag. About 80% of the screws on this are M3s, and 18% are M5s, rounding out the remainder of these M4s. And I'm guessing the only reason they use an M4 is for mounting the what was it? Actually, yeah, you have to use them on that. You have to use them on this. Yeah, it's basically just because of the parts that have them preset that way. So this is a spring-loaded mount, very, very schnookum, very nice. That will hold that nice onto the printer for us. All right, back to the manual and Z-end stop. So we're not building the Z-end stop because we're doing the tap, but let's look at it real quick. Hardest thing about this Z-end stop used to be, pulling the top off of this. They've redesigned this. So this is a press fit now. It's using a pulley inverted into a slotted block with a micro switch underneath it. What happens is you have a little micro switch is getting put in the bottom of this, and then there'll be a pin right here that basically hits that micro switch. It doesn't have enough weight to it as it sits to hit that switch down, but as soon as the tip comes down on it, it knocks it down and hits it, which is good. We're not using that though, again, because we're using the tap. We don't need that. The alternative version looks like it uses a little PCB board. And then there's an alternative to the alternative, which is called the sex bolt, I think it is. So basically it is similar to both of these, only instead of using a shaft, it has a specific kind of machine top on it, so it's a little bit bigger. So chances of missing it are relatively hard, and you can get those kits from different places as well. And then that would be mounted on the back side of your build plate. Make sure it's not touching. There should be a couple millimeters, what is it saying? Yeah, right there, 1.5 millimeters away from build plate. Basically you want it close enough so your tip is able to hit it. At least try to hit it on the center of it. You don't want it so close that you're scraping against your build plate. If you do that, you're gonna have troubles. You're gonna have some odd Z issues. XY end stops. We already installed our XY end stop. We used a board. This right here is if you build your own with your switches. Not a big savings either way. The boards are cheap. Installing it with switches is easy. You just have to do a little bit more wiring. And there you go, it's actually showing it. So there's a Hall effect version, which uses magnets, and a micro switch version, and a micro switch version without PCB. And let's see, where else are we? And then there's a cover plate, it's already on the printer. And mains distribution, using Wagos, that is this guy right here. Wagos, if you're not familiar, are basically clamp down wire connectors. So basically these are 5-spot Wago connectors, so you put a wire in every single port. So you put a wire in every single port, wire, 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 and then as you clamp them down, those wires are basically held in place. That just feels awesome to do that. The LDO kits doesn't call for this, but this is what that looks like if you're using it. This is a printed part. These you buy. These are Wago 221s. 221s, 415s. So they do make 221s that have different size wires. You want to make sure you get the right ones for this calling. Let's see, back to the PDF again. Let's see here. So upside down assembly, this is where we start putting on parts onto the printer, including the power inlet and the other parts. And this is the part where I come back and I say, I really appreciate you watching. If you have any questions or anything, comment. Leave me a like if you can, if you get a moment. If you watched through the whole video, tell me what you thought, you know? Another few days, I'll release another video with some more of the build. We're gonna start putting the electronics on this thing. If you haven't checked out any of the backlog of videos for this particular build, ton of stuff going into it. 4K camera, tap, stealth burner, clockwork 2, extrusion backers, bunch of stuff. So if you haven't watched those videos, go back and watch those ones. If you have, I appreciate it. One last time, like buttons, subscribe, and I'll check you next time.